A NAND gate. This is a digital logic gate, stands for not and. First it does the AND input, then inverts the results. The symbol for the AND gate, for the NAND gate, sorry. The symbol for the NAND gate is this one, with two legs. For the two legs, here is an output which have been inverted. The NAND gate circuit is as shown. We have two transistors, transistor 1 and transistor 2. This is the load resistor. The output is trapped here. It has been shown by the light emitting diode. Also, we have the base resistors. We have resistors at the input, two resistors at the input. Also, we have two switches, switch 1 and switch 2. Also, we have the supply. So, typical have been designed, as you can see here. Is designed, you can see here. This is the circuit for the clear circuit for the NAND gate. The working principle of the NAND gate is that the output will be 0. The output will be 0 if all the inputs are 1. If all inputs are 1, suppose this is the switch 1 and switch 2. If all switches are closed, if all switches are closed, means switch 1 is on and switch 2 is on. So if the switch 1 is on and switch 2 is on, no results on the light emitting diode. No results on light emitting diode if switch 1 is on and switch 2 is on. So whenever we open the switch, in either switch is opened, whenever either switch is opened, the diode will show the result. Diode will show the results, as you can see here. Switch 1 is open while switch 2 is closed. Or you can close switch 1 and open switch 2. Open switch 2. Switch 1 is closed, means switch 1 is on, while switch 2 is off. Or switch 1 is true, switch 2 is off, switch 2 is false. The result is similar. Or when all the switches are open, switch 1 is open and switch 2 is open. Switch 1 is open and switch 2 is open. This is switch 1 which is open and switch 2 is open. The diode show the similar results. So in this case, the working principle here, 1, 1 is 0, otherwise is 1. 1, 1 is 0, otherwise is 1. True, true is false, otherwise is true. True, true is false, otherwise is true. This is the working principle for the NAND gate. The truth table for the NAND gate is, as you can see here. Here it is the truth table for the NAND gate. The truth table for the NAND gate. 0, 0 is 1. 0, 1 is 1. 1, 0 is 1. 1, 1 is 0. What is the real life application for the NAND gate? Real life application for the NAND gate. NAND gate, this is the universal logic gate. A universal logic gate. In this case, you can build the AND gate or gate, not gate from only one NAND gate. So in this case, this is common in electronic hardware. Examples, number 1. In a building, the other logic circuits. In this case, in case of computers and the integrated circuits. Where is it? In case of CPUs, memory chips, and the digital control systems. In this case, manufacturer often use NAND design only. In this case, can reduce complexity, also can reduce the cost. So in order to reduce cost and complexity, they can use only NAND gate design. Also using digital memory in case of flip-flops or latches. Where it is, in case of RAM and registers. So why NAND gate? Why NAND gate? The NAND gate can be connected in a feedback structure to store a bit as long as power is on. You can use to store a bit as long as power is on. Also is used in data validation. In this case, the scenario here, the start motor only if both safety signals are okay. So if your safety signals are permit signals, you can use NAND to create an output like block when permit A and permit B is true, or invert logic as required by the system. Also, it is used in high-speed switching or clocked logic, where in timing and control circuits. For example, in signal processing and communication hardwares. Why NAND gate is used? The NAND gate are fast. NAND gate are fast and practical for implementing logic gates effectively. Okay, you are welcome again to the other logic gates or other circuits. Thank you. You are welcome. Thank you for watching.